Good afternoon, everyone. I want to continue our topic, scalar and vector. So, I want to solve problems. I want to apply those formulae that we've learned and let's see how to apply most of them. Now, the first question here, a quantity which requires magnitude and direction to be specified. So, this is just asking for an example of a vector quantity because this is magnitude, direction, that's vector quantity. So temperature is not a vector quantity. Distance is not a vector quantity. Displacement is a vector quantity. So that's our answer. Mass is not a vector quantity. Good. Now, this is a question for the next page. Let's see what the question is. Which of the following quantities listed are vectors? Let's go and mark this one that are vectors. Vectors, electric potential. What did I tell you about potential? Potential is defined in terms of work done. So this is not a vector. Torque is a moment of force. Torque is a vector. Kinetic energy, anything energy work is not a vector. Momentum is a vector. So our answer is torque and momentum. 2 and 4. 2 and 4. That's not our answer. 1 and 4. Oh, this one's supposed to be, sorry, this is a mistake. This one's supposed to be 2 and 4. 2 and 4. So this is supposed to be 2 and 4 because electric potential is not, it's a scalar. Torque is a what? Vector. Energy is a what? Scalar. Momentum is a what? It's a vector. So take note of that. Now let's go. We want to solve this question. The value of the resultant vector is this. Good. Don't forget the law. This is what? Triangle law. I can draw the cisnation also here. That will now make me to be able to join the resultant force. I see. This is the resultant force. This is the angle the resultant work with the horizontal. But I don't need the angle. They're asking for the magnitude only. Good. The beauty about this is a right angle triangle. So I'm going to use Pythagoras theorem. Look at the formula. The formula says R equals to, okay, that is going to be A squared, that is C squared, plus H squared, plus 2 times, plus 2 times 6 times 8. Remember the formula, or I should say the formula again. Let me write out the whole formula again. R equals to square root of A squared plus B squared plus 2AB cosine of the angle between the vectors. The angle between the two vectors is 90 degrees. You can see this is the angle. This is the draw for it. This is 90 degrees. So now cosine of 90 degrees is 0. Try it. Cosine of 90 degrees is 0. So this part will be 0. So we just need only this part. So R will be square of 6 squared plus 4 squared. No, plus 8 squared. So 6 squared, that is 36, plus 64, that is 100. So square root of 100 is what? 10. So this is our answer. I see how simple it is to apply the formula. We don't need to find the direction because the option does not show anything like direction. Now, let's look at this. They said which of the options give the correct relationship between the vector? When you see a vector like this, you have to look at the diagram, the one that is flowing, the one that is not flowing with them. Now, I'm starting with Q now. Look at this. This is Q. Q is going in this direction. Move to this direction. It still flows with R. I see that Q and R flows together, but it is against P. It doesn't flow with P. So P is the what? Resultant. So it means that vector P equals to vector R plus vector what? Q. So option A is our answer. Now let me even, because we are still going to do that under equilibrium. What if the vectors? Okay, let's leave that so that you don't get confused. When we get to equilibrium of vectors, we are still going to apply the triangle law. But let's keep that for now. Now look at this question. The resultant of two vectors is 50 Newton. If the forces are perpendicular to each other, now this is what I'm telling us. They're telling us that we have two forces that are perpendicular to each other. So we don't know what the forces are. Yeah, we don't know what the forces are, but we are told that their resultant, the resultant will be the one that comes out from their center. The resultant is 50 Newton. Good. So one of the forces is on the horizontal, the other one is on the vertical axis. Now, the next information is, and one of them makes an angle 30 degrees with the resultant. So this is the resultant. One of them makes an angle 30 degrees. So I can use anyone. This is 30 degrees. So I can say the one on the X makes 30 degrees with the what? With the resultant. They want me to find the value of that. Good. You know that when we are going to solve this, so that we can know the value of this vector 50 Newton along the X direction. That is what we call resolving vector. So now that's going to be 50 cosine 30 degree. What is cosine 30 degree? You need to know your reference triangle. Cosine 30 degree. Cosine 30 degree, that is r adjacent over hypotenuse, that is root 3 over 2. Root 3 over 2, that is 0.8660. 0.8660. So 50 times 0.8660. Let me use my calculator. 50 times 0.8660. 43.3 Newton. 43.3 Newton. So this is going to be our answer. I hope you're following. Now, okay, good. This is a question. Two identical forces, 100 Newton, act at a point at an angle of 120 degrees to each other. What is the resultant force of the two forces? Now, look at this. It's just like this. Angle 120 degrees. One vector is like this. The other vector is like this. No. I want to, yeah. One vector is like this. Don't forget they are identical. So their length should be almost the same. You don't need to measure them anyway. 100 Newton, 100 Newton. And the angle between them is 120 degrees. So we are still going to apply our formula. R equals to square root of A squared, that is 100 squared. 100 squared, that is 10,000 plus 100 squared, that is another 10,000, that is 20,000. Then 2 times 100 times 100. 100 times 100 is 10,000. Then times 2, that's also 20,000. Then multiply by cosine of 120 degrees. 120 degrees. Now, how do you compute cosine of 120 degrees? These are things that you learn from trigonometry. So let's see. This is all student take chemistry or student take chemistry. Now, this is the first quadrant is 90 degrees. The second quadrant is 180 minus theta. So 180 minus theta. So I'm going to equate that 180 minus theta. I will equate it to 120 degrees that I want to find because that angle 120 degrees is in the second quadrant. So I'm not telling you to get used to this now. You're going to learn this in mathematics, and some of you must have learned it when you are writing your ahead. So instead of finding cosine of 120 degrees, I can just find cosine of 60 degrees because when I solve this thing now, I create it to 120. Theta will go to this side. 120 will come here. 180 minus 120. Theta is 60 degrees. Theta is 60 degrees. So I'm going to get cosine 60 degrees. Is going to be cosine 60 degrees is going to give me minus 0.5. That should be minus 0.5. I just need to get this because that quadrant is not for sine. It's not for cosine. So minus 0.5. So don't allow that to bother you. That is not the part of the physics. You ought to know how to find angles because you are not going to be allowed to what to use your scientific calculator. That's why I didn't try to use any. So now R is going to be times this cosine this times minus 0.5. So what we have there is this 10,000 10,000 plus 10,000 plus 2 times 10,000 times cosine of 120 degrees. And cosine of 120 degrees is minus 0.5. So when you multiply 2,000 by 0.5, you're going to get, when you multiply 20,000, not 2,000, 20,000 by 0.5, you're going to have 10,000 minus 10,000 because there's negative sign. Minus 10,000 divided by this. So R is going to be what? 10,000. So now our resultant force is going to be 100 Newton. Our resultant force is going to be 100 Newton. So let's go and find, because this question asks about resultant force. It did not ask about magnitude of resultant force. So you are going to calculate the angle the resultant force make with the what? Horizontal. Make with the horizontal. So now we already know the force that's at the top. Okay. So now tan phi is going to be 100 sine 120 degrees over 100 plus 100 cos 120 degrees. 100 plus 120 degrees. So this is going to give us 100 sine 120, 0.8660, 86.6. This one is going to give us half minus half times z. That's going to be minus 50 over 50.0. So tan alpha, we can stop at tan phi there because we are not giving calculator to do this. So our option will contain tan phi instead of just phi. So let me punch my calculator for this. Calculator. Okay. What I have to do with calculator, 86.6 divided by 50. So that's going to be 1.732. 1.732. So that's going to be the for my alpha. If you are allowed to use a scientific calculator, we'll have been able to just find the arctan of this. So take note. This just to make sure that you apply all the formulae that you have learned there. So make sure you study very well, and you can always send your questions and challenges across to me. So thank you very much for your time. God bless you.